The statement 30 conductor limit shall not apply means derating isn't necessary until you have more than 30 current carrying conductors in a wireway. This differs from conduit derating rules where derating begins with only 3 conductors. In this case, with 350 current carrying conductors in an 8x8 wireway, you must consult National Electrical Code Table 310.15 B16 for derating factors. According to Table 310.15 B16, having 350 conductors requires a derating factor of 0.45. This means the allowable ampacity of each conductor is reduced by 45%. For example, a number 12 conductor typically has an allowable ampacity of 20 amps. Applying the 0.45 derating factor reduces this to 9 amps. 20 amps times 0.45 equals 9 amps. Therefore, number 8 conductors would be necessary. To understand this better, it's helpful to break down the relevant sections of the National Electrical Code and how they interact. Firstly, Article 520.6 specifically addresses wiring in theatres, and it makes an exception to the standard derating rules that apply to wireways and auxiliary gutters. Secondly, Article 366.6 covers auxiliary gutters. Normally, when you have more than 30 current carrying conductors in a wireway or auxiliary gutter, you need to derate the conductor's ampacity based on tables found in Article 310. However, Section 520.6 modifies this requirement for theatres. Thirdly, Article 376.22 discusses metal wireways and states that derating is not required until you exceed 30 current carrying conductors. After exceeding 30 conductors, you must refer back to Table 310.15 B16 for derating factors. Let's look at the concept of ampacity derating. Ampacity refers to the current carrying capacity of a conductor, meaning the maximum amount of current, in amps, a conductor can safely carry without overheating. When multiple current carrying conductors are bundled together in a confined space, like a conduit or wireway, the heat generated by each conductor can raise the overall temperature within the enclosure. This increased temperature can degrade the insulation of the conductors and potentially lead to a fire hazard. To prevent this, the National Electrical Code requires that the ampacity of the conductors be derated or reduced based on the number of conductors in the enclosure. The derating factors are specified in Table 310.15 B16. Now let's consider the impact of the exception in Section 520.6. Because this section states that the 30 conductor limit shall not apply, it means that the normal derating requirements for wireways and auxiliary gutters are waived up to a certain point. Instead of immediately derating when you exceed 3 conductors, you can run up to 30 current carrying conductors without any derating. However, once you exceed 30 conductors, you must revert to the standard derating factors in Table 310.15 B16. In a specific scenario, with 350 current carrying conductors in an 8x8 wireway, the exception in Section 520.6 allows you to avoid derating up to 30 conductors. But since you have significantly more than 30 conductors, you must apply the derating factor from Table 310.15 B16. As we previously determined, the derating factor for 350 conductors is 0.45. This means that the allowable ampacity of each conductor is reduced to 45% of its normal value. To determine the appropriate conductor size, you need to consider the load that each conductor will be carrying. For example, if each conductor is supplying a lighting fixture that draws 8 amps, you would need to select a conductor size that has an allowable ampacity of at least 8 amps after derating. To calculate the required conductor size, divide the load current by the derating factor. In this case, 8 amps divided by 0.45 equals 17.78 amps. This means that you need to select a conductor size that has an allowable ampacity of at least 17.78 amps before derating. According to Table 310.15 B16, a number 12 copper conductor has an allowable ampacity of 20 amps. However, after applying the 0.45 derating factor, the allowable ampacity is reduced to 9 amps, which is not sufficient to carry the 8 amp load. A number 8 copper conductor has an allowable ampacity of 40 amps. After applying the 0.45 derating factor, the allowable ampacity is reduced to 18 amps, which is sufficient to carry the 8 amp load. Therefore, you would need to use number 8 conductors in this situation. It's important to note that this is just an example, and the actual conductor size required may vary depending on the specific load and the type of conductor being used. It's always best to consult with a qualified electrical engineer or electrician to determine the appropriate conductor size for a particular application. To summarize, here are the key steps to follow when determining the appropriate conductor size for a wireway or auxiliary gutter in a theatre. Firstly, determine the number of current-carrying conductors that will be installed in the wireway. Secondly, if the number of conductors exceeds 30, consult Table 310.15. 16 to determine the appropriate derating factor. Thirdly, determine the load that each conductor will be carrying. Fourthly, divide the load current by the derating factor to determine the required conductor ampacity before derating. Fifthly, select a conductor size that has an allowable ampacity that meets or exceeds the required ampacity. Sixthly, ensure that the selected conductor size is also suitable for the voltage drop requirements of the circuit. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends that voltage drop be limited to 3% for branch circuits and 5% for feeders. To minimize voltage drop, you may need to increase the conductor size. The ampacity of a conductor is also affected by the ambient temperature. If the ambient temperature is higher than 30 degrees Celsius (86 degrees Fahrenheit), the ampacity of the conductor must be further derated. The derating factors for ambient temperature are specified in Table 310.15. B2. In addition to derating for the number of conductors and ambient temperature, it's also important to consider the type of insulation used on the conductors. Some types of insulation have a higher temperature rating than others. Conductors with a higher temperature rating can carry more current without overheating. The type of insulation is indicated by a letter code on the conductor, such as THHN or XHHW. When selecting conductors for a wireway or auxiliary gutter, it's important to choose conductors with the appropriate temperature rating for the application. It is also important to ensure that the wireway or auxiliary gutter is properly sized for the number of conductors that will be installed in it. The National Electrical Code specifies the maximum number of conductors that can be installed in a wireway or auxiliary gutter based on its size. Overfilling a wireway or auxiliary gutter can cause overheating and damage to the conductors. In addition to the National Electrical Code requirements, there may also be local codes or regulations that apply to electrical installations in theatres. It's important to check with the local authorities to ensure that all applicable codes are being followed. When working with electrical systems, it's always important to prioritize safety. Before working on any electrical equipment, be sure to disconnect the power and verify that the circuit is de-energized using a voltage tester. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical systems, it's best to hire a qualified electrician to do the work. They have the knowledge and experience to perform the work safely and correctly. Always follow the manufacturer's instructions for any electrical equipment that you are installing or using. Improper installation or use of electrical equipment can be dangerous and may void the warranty. Be aware of the potential hazards associated with electrical systems, such as electric shock, arc flash, and fire. Take precautions to avoid these hazards and protect yourself and others from injury. Never work on electrical equipment while standing in water or on a wet surface. Water is a good conductor of electricity and can increase the risk of electric shock. Keep electrical equipment dry and free from moisture. Moisture can damage electrical equipment and create a safety hazard. Inspect electrical equipment regularly for signs of damage or wear. Replace any damaged or worn equipment immediately. Use only approved electrical equipment that is listed by a recognized testing laboratory, such as Underwriters Laboratories UL or Canadian Standards Association CSA. Approved equipment has been tested and certified to meet safety standards. Do not overload electrical circuits. Overloading a circuit can cause the wires to overheat and create a fire hazard. Use the correct size and type of fuse or circuit breaker for the circuit. If a fuse blows or a circuit breaker trips frequently, it's a sign that the circuit is overloaded or that there is a problem with the wiring. Have the circuit inspected by a qualified electrician. Be careful when using extension cords. Do not use extension cords as a permanent wiring solution. Use extension cords only temporarily and unplug them when they are not in use. Do not run extension cords under rugs or carpets, where they can overheat and create a fire hazard. Do not plug multiple extension cords together. This can overload the circuit and create a fire hazard. Keep electrical cords and wires away from heat sources, such as radiators, stoves, and lamps. Heat can damage the insulation on the wires and create a fire hazard. Keep electrical cords and wires away from sharp objects such as knives, scissors, and tools. Sharp objects can cut the insulation on the wires and create a shock hazard. Protect electrical cords and wires from damage. Do not pinch, crush, or bend electrical cords and wires. Damaged cords and wires can create a shock hazard or a fire hazard. If you have any questions or concerns about electrical safety, consult with a qualified electrician. They can provide you with expert advice and guidance on how to stay safe around electricity. In conclusion, understanding the National Electrical Code requirements for wireway derating in theatre lighting is crucial for ensuring a safer and compliant installation. Remember that while the 30 conductor limit exception in section 520.6 provides some flexibility, it's essential to apply the appropriate derating factors from table 310.15. B16 when the number of conductors exceeds 30. By following these guidelines and prioritizing safety, you can create a reliable and efficient lighting system for your theatre.